6.2.2 reads, calculate the total amount of interest that paid will pay during the first year of the repayment of the loan. Now, when we make payments to loans, the payment does not only go into reducing the amount of the loan that we took, but it also goes into paying. So that's why you would see sometimes the amount of money you pay does not correlate with the money that is subtracted from your loan. Now, if you go and look at your answer sheet, you'll see that they did this in 3 ways. The first 2 ways, most importantly, they calculated the only difference between the first 2 ways is that the way they calculated the remaining balance after a year is different. But in both instances, they were just calculating the remaining balance after the year. And number 3 is quite different from them. So I'm going to go over the first answer. And for the second answer, it is the same. It is the same. They're trying to find the remaining balance again the same way. But the method that they used in number 3 is a bit different. Okay. So to calculate our remaining balance, what we're going to use is we're going to use this equation here. A, remaining balance, will be equals to P1 plus I to the power of n minus x1 minus I to the power of negative n over I. And we can get what is the remaining balance. So we will then say that is 2,350. And our I is 11, or let's use the decimal, to the power of 12, because it's just, we want to see how it grew within that year. And let's see the reduction it makes. So here we have our monthly payments of 536 rands and 95 cents. We have 1 minus 1 plus 0.11 over 12 to the power of negative 12. And everything again 0.11 over 12. And we should get that the remaining balance is 192,000 and 900 and look at that again, 296.17. That is the remaining balance. So what we want to also know is, what we want to now know is how much of it actually, how much of this money went into reducing the loan amount. So we want to know, how did our loan amount reduce? And how much of it went to the loan? So we would say the 2,000, what we initially borrowed, and we're going to remove how much of it went towards our loan by looking at how far we contributed to the loan, and we get that's 42,703.83. Okay, so that's how much now our loan amount has reduced by. Now we want to know, okay, that's how it reduced by, but how much have I paid so far, right? So within that year, how much has the person paid so far? So far, Beat has made 12 payments, so that's going to be 5,536.95. All of these is in rands, right? Multiplied by 12, and this will give us 66,443.57, comma 40. So this is the amount it has paid in total throughout the year, but this is the amount his loan only reduced by. So the difference between what his loan reduced by and what he has paid is the interest he has paid. So the interest would be equal to then and that gives us 23,739.57. Right. And this is the amount of money that has gone towards paying interest. Now, let's look at the second method. So, in method 3, what they did is, let's draw a timeline to imagine this. So, here is Pete borrowing the money here. Here's Pete borrowing that money here. And what they want to do is they want to pretend as if Pete did not necessarily pay those 12 months. He didn't pay 5,500 and something every month. What Pete did is Pete made a lump sum. So in the equation, they are taking back those values to the beginning. They're making it present value. How much is it worth if Pete had made just one lump sum at the beginning of the year and did not pay every month, right? That is the pretense that we have right now. So let's look at what would be the lump sum that Pete has paid if we're thinking about how much he pays every month now. Because we are taking future values and we are bringing them to the present, we will calculate this as a present value. So we have P is equals to x1 minus plus to the power of over I, and we're going to go ahead and calculate what is this lump sum that Pete now needs to, 95, to make 0.1 over 12 for 12 months divided by over 12. Now this is now the lump sum that we are calculating. And we get a lump sum of 62,648.18 That's the lump sum that he's going to pay. So let's say that Pete pays that, and now what is remaining in his account? So there's the loan amount, and Pete goes ahead and pays this lump sum at the beginning, and he now owes, like we're still at the beginning, this is how much Pete owes at the beginning. And we understand, still thinking that Pete is not paying anything, this amount needs to grow within that year, right? So what does it grow to? Using our compound interest equation, we will calculate what does this amount then grow to within that year. And it grows to 1,912 Let's write that down. 296. 17. This is what this amount now grows to. This is our opening balance at the end of the year. We paid that lump sum, we waited the whole year, the money has grown into that. Now, we still understand that this was his initial loan. That's the initial amount on the loan. So we want to then, again, the same thing we did the last time, see what is the difference between the amount that he owes and the balance. This will tell us how much money went to the loan. So how much money went to the loan? Will still be equals to this value, the original, minus the balance. And that should give us the same value we did before of 62,000. It's 42,703,83. 42,703,83. Okay, that's how much went to the loan. Okay, understand that. And how much has he paid in total? So the first part was just for pretense, so we can understand why they did what they did. But in reality is that he's been paying those 5,000 every month. So how much has he paid in total? It would be those 5,360.95 cents multiplied by 12, which gives us that value again of 66,443.40. And the interest, the money that goes to the interest, would be the difference between what he paid and what's the difference between the loan amount and the balance. So how has the loan reduced? And that should still give us the same value that it did before, which is 23,739.57.